Hello, we're ready to finish up Chapter 3. We have some more things to talk about classes, and I'm going to do this in an iPython notebook. So first, in the third week here, I've added some instructions for installing it. Since you've already installed Python on 3 on either your Mac or PC, this will give you instructions for installing it, iPython notebook. And once you've installed iPython notebook, there's also instructions for starting it. But the way you start it is you open up your terminal command prompt or PowerShell program. And I have mine open here. And you just type iPython notebook. Now, iPython notebook is a browser environment where you actually create a document. And I'm going to be reviewing a document I've written. But the unique thing about it, besides just being like a word processing document, is you can add code, and the code works. So we'll go ahead and hit enter, and it starts up a server, and you leave your command line running because the server will be running the whole time you're using iPython notebook. And then it should automatically open up a window in your browser that goes to an internal basically page that server is doing. And it's going to show you your file system. So while that's happening, we'll leave this page here, and you'll see it's at the root of your file system. I actually want to end up in downloads, so I'm going to go there. And then I'm going to go over back to our course, and then I'm going to show you these instructor notes are in iPython. So I'm going to be referring to those, so I'm going to open those up. So what I'm going to do is click here. Now if you just click here, it shows you a web page that's out on the web where I've published my page, and anyone can refer to that. You just give them the link to it. But it has a download icon, and if you download it, you can now access it from running this Python server, and that allows you to modify it or add to it. iPython notebooks are becoming really popular in science because scientists can do all their statistics and data collection and also their documentation and even write articles in this page. And then they can share it with other scientists, which can add their work or refine it or change it. So it's also a collaborative tool that way. So I'm going to go ahead and download this page. And that's going to go to my downloads folder. So I'm going to go back over to iPython downloads, which I've opened. And you'll see here's the notebook here. Python intro functions and objects. So we're going to open that. So now we're actually open in the iPython notebook environment. And on that original link I showed you, there's some links that you can go play videos on using this. They're quite long, so I didn't require you to read them. But let's go ahead and start here. So at the very last video, we didn't get into this, but in defining functions, they give an example of a function, which is implementing Newton's method for a square root. So in the book, they basically introduced this method here. And just a little orientation here. So we're in an iPython notebook. It gives us the name here. It automatically saves things. If you want to change the name, you just click on the name. It has a menu here of different things you can do. You basically are working in cells. The cells have these numbering scheme. And then you can also have cells that are formatting. So there's a couple types of cells. When you look at cell and you look at cell type, there's code cells, which you put Python. There are Markdown, which is a special simple language for doing word processing. There's raw cells, which you can type in basically HTML codes. And then you can just have a cell that has a heading. So that's how you do headings, where you just want a cell that's all that's in it. This is a code cell. So we have a definition and a little thing to call it. So this particular one gives you an average of things in a list. So you can see the for loop for a list, and then once it accumulates the total, it divides it by the length of the list. And so you pass that a list, and it gives you the average. Now to run this cell, you can click on it, and you just hit run, and it shows you the result right here. Okay, and then here's a documentation cell. So this is introducing Newton's method for calculating a square root. So his method is to take a guess, start with some guess to what it is and divide it by 2, and then basically see how close it is. So you replace the guess, and then if it's not close enough, you replace that guess with 1/2 of the guess plus n divided by guess. And that gets you closer, it turns out. And then you keep repeating step 2 over and over until your answer is close enough to the square root. So what is it close enough? We'll see here. So here I've defined square root of n. You get an initial guess, you just take the original number divided by 2. And then for k and up to 20, that should give us a good approximation if we do this 20 times. We set a new root equal to 1/2 the root plus n divided by root. And that'll give us a closer guess. And once we've done this enough, we just return it. So I have for I in a bunch of different numbers, print the root of I is the square root of I. And you can see here's the original number, and here's its best guess. Okay. So a better version is to do it until it's close enough. And this is what a lot of things do. So basically I've modified the original thing. This is not in the book. I'm just showing you some numerical analysis techniques. Numerical analysis is a field of math and computers that deal with how do we get computers to do accurate math. So if you want to do a cosine or an arcsine, numerical analysis people were the ones that figured out how to do that. The other big thing it has to do with is if you've ever used curve fitting, like a program like Illustrator where you can draw a smooth curve, how that curve is drawn and stored is based on math that was developed by numerical analysis. So here we're going to loop, and we have some other variables. We have a difference, which is what's the difference between this and the square of the number we're looking for. And then we have a count. So what we're looking for, while the difference is greater than 0, it gets a new root. It looks at the difference between the new root and the old root, so it's basically looking for that to become small enough. And then it creates the new root and increments a count. It prints a little statistics about how many times it's looped, and then returns the loop. So this is basically running until it's really close. And I have it as long as it's greater than 0, so that'll be an absolute orientation. And so you run it and you'll see it actually gets a little better precision. Let's see, does it? No, it turns out 20 times is better, but you'll see it prints out the count here, and it doesn't need 20 times to get to the accurate thing. So why this is better code is it doesn't loop 20 times. Usually it will finish when it's completely accurate. So now, object-oriented programming, we covered this first part of this. So these are notes that I had made on the first part of the object-oriented part. We're just going to point out, I did point out in these notes, there's a thing that people that do object-oriented programming use, which are called UML class diagrams. UML stands for Unified Modeling Language, and it's very popular in some companies, especially IBM. And so you use graphic diagrams to not only document your class that you design, but also document all types of things in programming. And this, we're just going to talk about the class diagram because you'll run into these in your career. So when you draw a UML diagram, you usually draw 3 parts. The first part is just the name of the class, and the last part lists the methods, which is the interface to the class. And then the middle part is just the data that you're going to store in the class. And these are usually private to the class, so that normally people access these by going through the methods. But it's a really simple diagram. UML actually has a little bit more complex syntax here. So this is an informal type of UML that I use in my, my classes where I talk about object-oriented design. Now, a lot of methods are always in a class. They usually always have a constructor, you have string representations, you have a method to get and set the data, and so usually you don't list those in the UML diagrams because they're kind of standard. So So now we get into, we talked about adding the add operator, and that's covered in my other lecture. So we're going to skip down to inheritance. So inheritance, when you look at the book, he starts to introduce the gates class, and we'll talk about that in another video. But inheritance is when you create a class that's going to stamp out objects. Sometimes it's useful to make that class start with attributes of another class. And we use this in lot. It's a very important tool in object-oriented programming and in terms of abstraction. And so we're going to show you an example of that. So inheritance can be defined as a process where one object acquires the properties of another. And actually how you do this is when you define your classes, you say the class that defines this type of object will actually inherit the properties of an object defined by another class. So you define inheritance with the actual classes. Common terms that are used for inheritance are the word extends or implements. And this is a very special verb that computer scientists use to describe inheritance. They say that one object is a type of another. So the is a relationship is a way of saying that this object is a type of that object. And we're going to see some examples of how that's interpreted. So what does it mean that you're a type? So if you're a type of object, it means that you have an interface, and so people expect that interface to be a certain list of methods they can call. So if you are a certain type of object, it means you provide all those methods.